Today we're going to solve radical equations. And with solving radical equations, basically what we have to do is we need to get rid of the square root. Okay? And we're going to simplify it. So we had a couple of examples here we did in the warm-up. Took the square root of both sides. We're golden. Now, the only thing is that sometimes there's more information on one side of the equal sign than just the radical. So the first thing you have to do, numero uno, okay? First thing we do is we isolate the radical. Okay? Montana. What would it mean if I isolated you? Did what? Try again. All right, Mr. Farmer wants to help you out. What does it mean?
Isolated means like put away from everybody else.
Okay, so might stick you outside, but I'd put you by yourself, okay? All right. So if I want to isolate the radical, that means I want to, okay, put it by itself, okay? All right, so you're going to remember that now, aren't you? Okay? So here I have square root of x minus 4 equals 5. Is that minus 4 under the radical? No. So that means I need to get rid of it. First of all, I need to isolate the radical. Get him alone. So I need to use one of those special things I've done about solving equations and add 4 to both sides. Okay. Step 2. Once we isolate the radical, we're going to square both sides. So we square both sides, we get x equals 81. Now, I'm not going to spend the time on it, but not because I don't think it's important. Okay? And I will show you why it is important. But it is very important that you check your answers. Okay? All right. You need to check your answers, because we're going to get into situations where your answer doesn't work. Okay? You're going to learn about something that's called extraneous solutions today. Okay? So you got to make sure you check your answer. I don't care if you check it on a calculator or what. So if you pull out your calculator, take my calculator, square root 81 minus 4 equals 5. Great, did it right. Okay? But you're going to need to show it to me on you're going to want to do it somehow, all right? Even if you write checked on calculator, or if you actually show it to me that you did square root of 81 minus 4 equals 5, 9 minus 4 equals 5. So when you actually do check things, both the last two lines should be the last line should be exactly the same. Okay, 5 equals 5. All right. All right, letter B. Okay, first of all, we want to isolate the radical. I look at it. Square root of x plus 3. Is everything under the radical? Okay, so is it isolated? Okay, it's all by itself on the left side. Okay, whatever, everything under the radical. There's just a radical there. Okay, all right. So now I have to square both sides then. What do I get when I square the square root of x plus 3? Okay. All right. The square root and the radical, or the square and square root, eliminate each other or undo each other. So I get x plus 3 equals 49. Subtract 3, and x equals 46. All right, checked it. So make sure you check your answers. Okay. Oh, we got another one down here. Yes, sir. Okay. Now, all right, so what do we say? Step one is to isolate the radical. That means if there's anything else on the same side as the radical, I have to get rid of it. So in this situation, I need to get rid of this 6 first. You must do it that way. If you don't, your answer will more than likely be incorrect. If you get it right, I would be amazed in this case. All right? So we're left with square root of 5x plus 1 equals 4. Now, what I've seen happen before is people try to square, okay, first, and you can't do that. All right, because you have, remember, the one thing is if I tried to square it first, it actually means I have this. Okay. How many of you want to do that multiplication? Okay, all right, okay. You don't, so don't do that. All right. Now, I've isolated the radical. Now I'll square both sides. So we get 5x plus 1 equals 16. So how many people got 3? All right. Good. Montana, did you get 3? Okay. All right. So then x equals 3. We subtract 1. That gives us 15. And 15 divided by 5 is 3. And it's important that you check it, whether it's in your calculator or wherever. Okay. In my calculator here, square root 5 times 3 plus 1, and then plus 6. All right. Oops. I do that sometimes. Like that. There we go. All right, we got 10. All right, what we wanted. Okay? All right. Where's the what 3 come from?
Oh, it's 5 times 3 plus 1.
Okay. All right. Okay. All right, so we had to add or subtract there. Now we're going to look at multiplying and dividing. But the whole point is you need to isolate the radical first. So I'm taking my highlighter here, and I'm going to highlight the radical. All right, see, there it is. Okay, is there anything on the left side besides that? Yes. So my first step is to get rid of that anything else. So in this case, we have multiplication going on, right? 4 times the square root of x. So to undo that multiplication, we are going to divide. All right. So dividing both sides by 4, first of all. Square root of x equals 8. So x equals 8 squared, which is 64. Okay? You must isolate the radical first. So if you need to, maybe you need to do what I did. Okay? Maybe you need to take out a pen or a colored pencil or something and circle the radical. okay? Or color it in so you know, hey, here's the radical part. Anything else that's not there, I need to get rid of. Letter B. So Angela, what do I do first here? All right, multiply both sides by 2. Good. Square root of x equals our friend 12. Okay? Dozen donuts is always good. Or a dozen eggs. Okay. Square, we've isolated it, so we square both sides. X equals 144. Okay. What's that? Hope so. Okay. All right. Isolate the radical. Oh, let's practice one of them. Over here, pause. X equals 100. How many people got 100? All right. Okay. So, how many of you multiplied by 5 halves first? Okay. How many people multiplied by 5 first and then divided by 2? Okay. Does it matter which way I do it? No. Okay. It's up to you. Okay. Up to you. All right. So you could have done either one. All right. Okay. Now, I have a radical on both sides. So if you have two radicals, all right, if you have an equation with two radicals, equation with two radicals, all right, we want them on opposite sides. Put it on opposite sides. Put on opposite sides. There we go. Okay, all right. Put it in good grammar English. Okay, or English grammar, whatever it is. Okay, now, if they're on opposite sides, we're good to go. Because to get rid of a radical, we just square both sides. Right? The nice thing about squaring both sides here is then, it eliminates both radicals. We get 2x minus 1 equals x plus 7. All right, so we'll put the radicals on opposite sides. And then our second step is we'll square both sides. And then solve. So we'll subtract x from both sides. And then add 1. So we should get to x equals 8. And then if I checked it, 2 times 8 is 16, minus 1 is 15. 8 plus 7 is 15. So we would have the square root of 15 equals the square root of 15. And those are the same. I have two radicals. Step 1 says to put the radicals on opposite sides. All right, I did it. Is that right? All right, we actually have to do it correctly, right? So we need to add the square root of 6 to both sides. Okay, so make sure you do it properly. Okay. Now that I have the radicals on opposite sides, I can square both sides. Five x minus 4 equals 6. Okay. Then we solve that equation. Add 4, 5x equals 10, so x equals 2. And then we need to check it. Square root of 5 times 2 minus 4 minus the square root of 6, does that equal 0? Let's see. 10 minus 4 is the square root of 6 minus square root of 6 equals 0. So yes, 0 equals 0. It's been checked. Check your answers. Okay, all similar things. Okay. Oh, we have 5, not 6. Okay, oops. Here. I just, there we go. Now, extraneous solutions is it. Do you realize that sometimes when you're solving equations, that having a little bit of common sense goes a long ways? Okay, now I know it's a reach for some people, but, okay, I want you to look at this problem. I mean, actually look at it and think about the reasonableness of it happening. If I start with 12 and I add a number to 12, can I get 6? I can if that number is negative 6, right? Can I take a square root and can I get a negative 6 from that square root? And the answer is no, because it says it's a positive square root in this case. So in reality, is this possible? No. So this is one of our good friends, Mr. No Solution. Now, let me just show you that if I solve this problem, okay, I isolate the radical. Square both sides. Oops. Then we get x equals 6. Okay? And there's no way that I can do 12 plus 6 and get 6. Okay, it would have to be 12 minus 6. And I can't get that from there. So that's not possible. there's no solution. Okay? All right, so if you go through the process, okay, and this is why either you need to be able to see it, okay, immediately, or remember to check your solution. Okay? Remember to check your solution. Okay? Part B here is going to be another one that gives us a similar result. Not the same, but similar. So I have one radical, right? So to get rid of it, we do what? Okay, square both sides. X squared equals 2x plus 3. Now remember all that practicing we were doing with factoring? Okay, here's another instance where we're going to use it. Okay, this is a quadratic equation. And whenever we have quadratic equations, we want them to be equal to 0. Okay? So anytime you have an equation that's got an x squared in it, is the highest term, you want it equal to 0. So the next step I need to do is get all this together. So I need to subtract 2x and 3 from both sides. So we get x squared minus 2x minus 3 equals 0. All right. Since I have a quadratic equation equal to 0, to solve it, I want to factor. Okay. I want to factor. So what do I get when I factor this very, very, very difficult quadratic function? Hopefully you remember how to factor that. All right. Krista, do you know? What are the factors of negative 3 that add up to negative 2? Okay, x minus 3 and x plus 1. So x equals what? They are the opposites, right? Okay. So we get negative 1, positive 3. Okay. Positive 3 here, that's what makes that equal to 0. Negative 1 makes that equal to 0. Now, okay, one of them doesn't work. Anybody know which one? I was waiting for it, you guys to say the 3. It's the negative 1 that doesn't work. Because the right-hand side cannot be negative because it says a positive square root of 2x plus 3. So this doesn't work. My answer is x equals 3. Okay. Now, all right, take out your calculator. All right, I know we're winding down. Take out your calculator. Go to your y equals. And I'm going to show you how you can see this on your calculator. Okay? In your y equals, on the left side, we're going to put square root, oops, nope, the left side was just x, wasn't it? Sorry. Okay, put x in. Right side, we have the square root of, what was it? 2x plus 3, right? Hopefully it's on your paper. Okay, now, zoom 6, graph it. Okay, here's our line y equals x. Here's our line square root of 2x plus 3. Okay. How many places do those two lines intersect? Excuse me. 1. So there's only one answer. Okay? So if I go to my table then, looked at the table, I can see that that answer is at, okay, I got two numbers here. Let me go here, down here. Okay. All right. At -1, y1 is -1, but y2 is +1. So they're not the same. So it couldn't be -1. At 3, they're both equal to 3. So 3 is a possibility then. Okay. Jared, do you have a question?
For question 2-6, it's saying invalid the
You have that plot on there. And turn that off. Now it'll work. Okay? All right, here's your assignment.